In this episode, we focus on something that shapes security long before a system is installed or a firewall rule is written: how software is built. Secure software development practices are the habits and rules that help teams create applications that are harder to exploit, easier to maintain, and less likely to expose sensitive data by accident. Beginners sometimes assume security is something you add at the end, like putting a lock on a door after the house is built. But software security works better when it is designed into the house from the start. The word embed is important because it means these practices are not occasional, optional, or dependent on one security-minded person remembering to do the right thing. They are built into the way teams plan, write, review, test, and release software, so that secure behavior becomes normal behavior. In payment environments, software often touches the most sensitive workflows, like checkout pages, payment processing services, and integrations with external providers, so small coding mistakes can have big consequences. By the end of this lesson, you should be able to explain what secure development practices are, why teams struggle to follow them without structure, and what it looks like when secure development is truly part of everyday work. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is understanding what can go wrong when secure development practices are missing. Applications can accidentally expose sensitive data, accept untrusted input in dangerous ways, mishandle authentication, or store secrets in places where they do not belong. Many of these failures are not because developers are careless, but because they are building complex systems under time pressure and making thousands of small decisions. If security guidance is unclear, inconsistent, or appears only at the end of the project, teams will naturally prioritize features and deadlines. Attackers take advantage of this because software often becomes the most direct path to data and system control. Beginners should notice that even strong network defenses cannot fully protect an application that is vulnerable, because the application itself is the gateway users and systems rely on. Secure development practices aim to reduce the chance that vulnerabilities are introduced and to increase the chance that they are caught early, when they are cheaper and safer to fix. That is why secure development is not a single tool, but a set of behaviors that shape the entire life cycle. Embedding security begins with planning and design, because the design phase is where teams decide what the application will do and how it will do it. Security at this stage includes identifying what data is sensitive, where it flows, and where it will be stored, because these choices define the application's risk profile. It also includes thinking about who will use the system and what kinds of misuse could occur, such as someone trying to impersonate another user or manipulate a transaction. A classic secure design habit is threat modeling, which is a structured way of asking how the system could be attacked and what controls are needed to prevent that. Beginners do not need to master formal threat modeling frameworks to benefit from the concept. They need to understand the mindset of looking for abuse cases, not just happy paths. If the design includes clear decisions about authentication, authorization, input handling, and logging, later coding becomes more consistent and less error-prone. Embedding security early is about creating a blueprint that includes safety features rather than hoping to retrofit them later. Requirements are another powerful embedding point, because teams tend to build what they measure and what they are asked to deliver. If requirements only describe features, security becomes invisible and negotiable. If requirements include security expectations, such as access controls, encryption needs, logging behavior, and data retention rules, security becomes part of done rather than an extra. Beginners should understand that requirements do not need to be long to be effective. They need to be specific enough that people can verify them. For example, instead of saying, "be secure," a requirement might specify that sensitive operations require strong authentication and that user actions are logged with meaningful context. When security requirements are clear, testers and reviewers have something concrete to check, and developers have guidance that prevents inconsistent choices. In payment environments, requirements may include constraints on storing card data, handling sensitive authentication data, and ensuring that payment workflows do not leak information through logs or error messages. Embedding security in requirements is like writing safety rules into the recipe rather than hoping the cook remembers them. Code practices are where secure development becomes visible, and this includes conventions that reduce common vulnerability patterns. Input validation and output encoding are foundational because many attacks begin by sending unexpected input that the application mishandles. Secure coding practices also include using safe patterns for authentication and session handling, avoiding predictable tokens, and ensuring that authorization checks are performed consistently. Beginners should recognize the difference between authentication, which is proving who someone is, and authorization, which is determining what they are allowed to do, because many real vulnerabilities come from confusing these two. Another important habit is careful error handling, where errors are logged internally with useful details but not shown to users in a way that reveals sensitive information. Developers also need safe practices for working with data, such as minimizing what is stored, limiting exposure of sensitive fields, and avoiding placing secrets in code or configuration files that might be shared widely. Embedding secure coding practices means teams agree on these patterns and reinforce them through reviews and training rather than leaving them to individual preference. Peer review is one of the most effective ways to embed security because it turns secure development into a team responsibility rather than an individual burden. When code changes are reviewed by another person, there is a chance to catch mistakes, question risky choices, and enforce consistent patterns. Beginners should understand that reviews work best when they are structured, meaning reviewers know what to look for and have simple checklists in mind, even if those checklists are not formal documents. Security-focused review points might include checking for proper authorization, validating that inputs are handled safely, ensuring secrets are not introduced, and confirming that logging does not include sensitive data. Reviews also help spread knowledge, because developers learn from each other's choices and corrections. Embedding security through review depends on making review a normal step for every change, not only for important changes, because small changes can introduce big vulnerabilities. A team that reviews consistently builds shared standards, which is exactly what embedding is meant to achieve. Automated testing and analysis also support embedding because they provide consistent checks that do not depend on someone remembering to look. Teams can use automated checks to find common coding errors, insecure dependencies, or misconfigurations in build and release processes. Beginners should think of automation as a guardrail, not a replacement for thinking, because it catches many routine issues quickly and frees humans to focus on deeper design questions. A major area is dependency management, because modern software relies heavily on third-party libraries, and vulnerabilities in those libraries can become vulnerabilities in the application. Secure practices include tracking dependencies, updating them responsibly, and understanding which ones are critical to security. Automation can also support detecting insecure patterns, like hard-coded secrets or risky functions, before code is merged. Embedding means these checks run routinely as part of the normal workflow, so security feedback arrives early and often rather than late and painful. Release practices are another place where teams either embed security or accidentally undermine it. A release is the moment software moves into a place where real users and real data are involved, so the release process should include controlled approvals, validation steps, and rollback readiness. Beginners should understand that even perfectly written code can be deployed insecurely, such as by enabling debug modes, using default credentials, or exposing administrative endpoints. Secure development therefore extends into how software is packaged, configured, and delivered. Teams should know which configurations are safe for production and ensure that production deployments consistently follow those safe standards. This includes ensuring that logs are centralized, that monitoring signals are present, and that sensitive data is protected in transit and at rest where appropriate. Embedding security into release means the release workflow enforces these requirements instead of relying on last-minute heroics. Another vital element is training and shared understanding, because people cannot follow practices they do not understand. Training for beginners does not have to be a semester-long course. It can be focused lessons on common vulnerability types, safe coding patterns, and how to think about risk. What matters is that training is ongoing and connected to real work, not a one-time checkbox. Teams also benefit from having secure development champions or mentors who help reinforce standards and answer questions, especially when new developers join. Beginners should notice that secure development is as much about communication as it is about code, because developers, testers, and security staff need shared language and shared expectations. If security guidance is delivered in a way that feels hostile or unrealistic, teams will resist it. But if it is practical and aligned with delivery goals, teams are more likely to adopt it. Embedding is successful when secure practices feel like part of craftsmanship rather than like an external burden. Secure development also includes handling data responsibly, which is especially important in payment contexts where data sensitivity is high. Teams need to minimize data collection, store only what is necessary, and avoid placing sensitive data in logs, analytics events, or error reporting systems. Beginners should learn that data can leak through unexpected channels, such as debug logs, crash dumps, or monitoring dashboards, and secure practices address those channels deliberately. It is also important to design for least privilege, meaning services should have only the access they need, and users should only be able to perform actions they are authorized to perform. When least privilege is built into application design, it reduces the impact of compromised accounts and reduces the damage from coding mistakes. Data handling discipline is not only about privacy. It is about reducing the value of what an attacker can steal and reducing the blast radius if something goes wrong. Embedding these habits makes payment applications safer by default. Teams also need to manage exceptions, because real development includes urgent fixes, experiments, and pressure to ship. If secure development practices are too rigid or unrealistic, people will bypass them, and bypasses are where risk concentrates. A disciplined approach includes a safe way to handle urgent changes, such as using a faster review path while still requiring peer review and basic automated checks. It also includes learning from incidents and near misses, updating standards when real problems show where guidance is unclear. Beginners should understand that embedding is not about perfection. It is about consistency, and consistency requires processes that can handle real-world variability. When teams handle exceptions openly and safely, they do not create hidden security debt that accumulates over time. Embedding means the workflow can flex without breaking, which is how security becomes a stable part of development culture. To bring this together, embedding secure software development practices teams follow is about turning security into a routine part of how software is designed, built, and released, rather than a last-minute inspection. Secure development begins with clear design decisions and requirements that define how sensitive data is handled and what controls must exist. It continues through consistent, secure coding patterns, peer review that reinforces standards, and automation that catches common issues early. It extends into release practices that prevent insecure deployment and ensure monitoring and logging remain intact. Most importantly, it relies on culture, training, and workflows that make secure behavior the easy default and exceptions manageable without chaos. In payment environments, where software often sits directly on the path to sensitive data, embedded secure development reduces vulnerabilities at the source and helps keep systems trustworthy over time. When teams truly follow these practices as part of everyday work, security becomes less about reacting to bugs and more about building systems that are naturally harder to break.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.